Hey everyone, this is Eat, Sleep, Physics, Repeat, and today we'll be looking at a vectors word problem. So it starts off by yacht A starting to sail from point L with a position of 5i minus 2j meters with a velocity of minus I plus 3j. Yacht B starts moving 10 seconds later with a velocity 2i plus j from position vector 4i minus 3j. T is the time in seconds from moment B starts sailing. Now we have to find, in terms of t, the distance between A and B after t seconds, when A and B will be 40 meters apart, and the closest distance of the two and at what time this occurs. So what I like to do is to always start off with a diagram. We draw where each of the yachts are, and we can see that the position there will be after t seconds. So what we have to do is to find the position of A and B after t seconds. We can do this by having our initial position, which is stated in the question, of 5i minus 2j. Now we add our velocity with our time. This basically gives us our position, and since yacht B starts moving 10 seconds later, our time in this case will be t plus 10, and we multiply this by our velocity minus I at 3j. Then we expand this out, giving us minus it minus 10i plus 3jt at 30j. And then we basically take out the I components of this equation, giving us 5 minus t minus 10, which gives us minus t minus 5, and our j components from this, such that it gives us 28 plus 3t. Now this gives us a final position of minus t minus 5i at 28 plus 3tj. Similarly, for our position of B, we have the initial position multiplied by the time and its velocity. We can then simplify this down through this expression over here. And then once we take out the I components, it gives us 4 plus 2t, and our j components minus 3 plus t. This gives us a final position of 4 plus 2ti plus minus 3 at tj. Now, we can actually use these two equations, and we can use the distance formula, which basically is coming from Pythagoras, and it states that the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. We can then substitute in these values, and it gives us an expression. We can just simply put this on a calculator to give us this simplified form. Now we've solved for part A, as we have found an expression in terms of the distance between the two yachts in terms of t. Now we can actually use this equation to solve for B, where A and B will be 40 meters apart. We can just then put in 40 as our d value, and then we can use our graphing calculator to solve for t, which gives us a time of 2.63. We've solved for part B. Now we have to find the minimum distance between the two. We can do this by plotting this equation into a graphing calculator, or in this case I use Desmos. Now we normally would just find the minimum point, but since t cannot be in the negatives, we have to put a constraint in such that time is greater or equal to 0. We then use this minimum point of 32.28 meters as our closest distance, and our time would be 0 just before B moves. So we have solved for part C. Overall, this was a very interesting problem, and I hope you enjoyed. Thank you.